So good morning, one and all. So after discussing the functional elements of municipal solid waste in the last lecture and the scenario of the solid waste management in India and abroad, the overall idea of the picture. Okay, now we're going to start with various characterization of municipal solid waste. Now, before actually starting this, I want to let you know what is exactly I'm looking for here in this lecture. I told you in the last lecture, I think so, when we were talking about municipal solid waste management or solid waste management in India, there's a huge lot of concerns as well as, like disposing, problems, concerns. So I gave you so many examples, if you really remember, starting from your home to your city, then your particular, national level and global level. So when I talk about national level, I think so I gave you example of Delhi, where the Mount Everest of the solid waste is giving a lot of concern to in and around that particular area. And the biggest concern for the management of Delhi management also, even for India also, to get rid of that kind of problem, because it's a now mixed waste which is making a heap over here there. So that's why we need to standardize the that particular options where we have a source separation of waste. Source separation means, I told you basically, when I took the example from the foreign countries, they have a different color coding of dustbins, like blue, green, red, all kind of stuff is there. So they have designated a different kind of waste for each kind of dustbin. So they have a source separation in that category. Okay. Now once we have a source separation, that's very easy to take care of a different kind of waste. Just hold on a minute. Sorry, Bata. Sorry for the interruption. So basically, in this lecture, what we are going to discuss, like you have a waste. It's very important, Beta. You have a waste, like it's in front of you. Now you have to decide whether this waste go for landfilling, whether this waste is going for composting, whether this is waste is going for burning and incinerator, which we are going to discuss in detail in the coming lectures, and what you are going to with that kind of waste. So you know very well, once you have a basic properties, basic characteristics of that particular waste. Like you are a mechanical engineer, it's fine when you're handling a material, raw material, to get it converted to final product using some machines. So when you have a material in hand, raw material in hand, so you must be knowing all the basic properties of the raw material you are handling. If you don't know, if you're not having a complete information about the raw materials, then it's very not easy to decide about the machine you want to use, the various processes or operations which are going to apply using the machines. Okay. So it's very important for a integrated waste management system. Okay. So once you have integrated waste management system, you need accurate and reliable data on waste composition, and the quantity is something very much important. Why this data is so much important? Because it is going to have a particular impact on the well organized and smooth management operations, and it really reduces the amount of waste generated. How? I want to tell you in the coming slides. Then you need to have this information for the optimal design and operation of recovery of and incineration facilities, which we're going to discuss in detail in coming slides. Okay. So before actually going into detail of this characterization of municipal solid waste, you must know first of all how we are going to do the sampling in that case, because I told you by taking examples in the last lecture. So it is a sampling protocol. Basically, you have a direct sampling, how the material flows, when the material flows. Then you need a survey. First of all, that particular area, in that area, what is the amount of wet waste, dry waste, in what season is coming. So it is up to you. You want to do this particular survey, and on the basis of survey, you want to design the facility accordingly. So this particular waste sampling, they are particular variable in nature. It depends upon season, it depends upon region, it depends upon household also. Okay. So there are householders which household basically when talking about they are producing more wet waste rather than dry waste. Whereas some other areas they are producing more dry waste rather than wet waste. So you need to decide accordingly for that. The first particular characterization part of the municipal solid waste is the ultimate analysis. And being a mechanical engineer, this term is very much important because when you go detail into your particular degree, the second year, third year, you'll come to know about these properties of the way of the product you are handling. Ultimate analysis. Ultimate analysis is the total elemental analysis. Okay, total elemental analysis. What is total elemental analysis? Abhi dikhane wala hu. It involves the determination of percentage value of carbon, hydrogen, oxygen, nitrogen, each and everything. This the waste which you have generated. Now the waste which you have, you need to have a complete analysis. में कार्बन कितना है, हाइड्रोजन कितना है, नाइट्रोजन कितना है. अब सोचो आपके सामने वेस्ट पड़ा है, आपको डिटेल एनालिसिस मिल गई है कि इसमें इंडिविजुअल एलिमेंट्स कितने हैं. ओके, देन यू कम टू नो अच्छा इसमें कार्बन ज्यादा है, हाइड्रोजन ज्यादा है, तो दिस कैन बी अ फ्यूल. You mechanical engineers know very well, because for getting a fuel, particular thing you want to convert it to fuel, you must have hydrogen and carbon in more quantities. Okay, sulfur should be low, ash should be very low. What is ash? Unburnt carbon. Okay, so this is something overall I'm discussing about. Now this is ultimate analysis. If you see the examples, fine. This is percentage by weight on dry basis. You have a different things over here. That is basically, I'm talking about, see this, carbon, hydrogen, oxygen, all these components are there. Now you have organic and inorganic. Organic means a fraction of waste which is having a more organic content. If you see the organic content, in organic content, carbon concentration is high as compared to other particular things. Okay, see this, if you're talking about organic, you have paper waste, plastic waste, food waste, and wood. You got different kind of waste coming from different kind of regions. So when you have paper, it has this analysis. So you have instruments, you have the sophisticated instruments at the designated areas. So you can really go for this kind of analysis. Okay, the waste which is coming out from the kitchen, waste which is coming out from home, waste which is coming from the industry or any particular region locality, you can have this kind of ultimate analysis. So ultimate analysis is going to give you the elemental analysis. के elements क्या क्या है. Okay, so my request all of you who are listening to this lecture, be particular while listening to this lecture or going through this lecture, because on the basis of this lecture we're going to solve certain numericals and you will get these kind of numericals in your exam also. Okay, so basically talking about ultimate analysis, and for glass, metals, mixed waste, you have more ash content. You know what is ash content? Ash is unburned carbon. So we don't require any undue amount of ash that is more than 10% or 20% ash for the fuel we want to handle. Because more ash, this means there will be more problems for disposable of ash after that. आप देखा होगा भाई वो जो गांव में बेटा वो कोल बर्न करते हैं या वो काउ डंग बर्न करते हैं, उसका नीचे ऐश बहुत बढ़ जाती है, तो ऐश को डिस्पोज करना बहुत डिफिकल्ट है. Not talking about small quantity, it's a huge quantity. When once you're talking about waste, I told you in the last particular lecture, it's a tons per day. It's a tons per day. तो इतनी हम वेस्ट बर्न करेंगे तो tons per day में ही ऐश प्रोड्यूस होगी. तो इस ऐश को हैंडल करना बहुत डिफिकल्ट है. कहाँ पे जाती है ऐश, विद टाइम आपको बताऊंगा इसके बारे में. So ultimate analysis is, remember what I mean, it's a elemental analysis. Okay, any doubt you can ask me later on. Now the second analysis under the chemical properties of municipal solid waste is a proximate analysis. Okay, now what is proximate analysis, beta? See this proximate analysis. Now ultimate analysis is going to give the elemental composition and proximate analysis will give you the capability of MSW, municipal solid waste, as a fuel. Okay ji. Now please now understand this kind of thing. रेडीमेड एनालिसिस आपको ये दे देगा कार्बन कितना है, नाइट्रोजन कितना है, हाइड्रोजन कितना है, ये सब कितना है, ये सब बता देगा. लेकिन प्रॉक्सिमेट एनालिसिस ये बताएगा कि व्हाई दिस वेस्ट कैन बी यूज्ड एज अ फ्यूल. जब मैं बताया था आपको वो टाइम आगे बताने वाला हूँ, मेरे लेक्चर्स में डिजाइन बताने वाला हूँ. फ्यूल में क्या है कि हम ऐसा रिएक्टर डिजाइन करते हैं जिसको बोलते हैं इंसिनरेटर बोलते हैं. उस इंसिनरेटर में मैकेनिकल इंजीनियर ही इसको प्रिपेयर करते हैं. इस इंसिनरेटर में हम क्या करते हैं, ये वेस्ट लेके जाते हैं जो वेस्ट प्रोड्यूस हो चुका है, बट वो वेस्ट की प्रॉपर्टीज में डिफाइन होना चाहिए कि दैट कैन बी यूज्ड एज अ फ्यूल. ओके, सो दैट कैन बी यूज्ड एज अ फ्यूल. Okay, so when that can be used as a fuel, that can be burnt inside the chamber in the called incinerator. So when it's going to burn inside the incinerator, it's going to produce a lot of heat. It is going to produce a lot of heat only when it is having a good calorific value, or as it can be serve, it can serve as a fuel. Okay, so when it can serve as a fuel, it's going to burn inside, going to produce a lot of heat. That heat is used to, I told you, I want to show you in the coming lectures also. This heat is used to, heat up the water to convert it to steam. So once steam is there, the steam is used to run a turbine, and turbine, now electricity is produced. So there's a huge concern. So you are burning a waste, right? See this, the fuel you are using it waste, and from the waste you are producing energy, and this is waste to energy, which I really discussed with you last time. So can you design this? Can you execute this? All depends upon these kind of things. So you cannot burn each and every kind of waste. Okay, so that's why you need to have a detailed characteristics of this kind of waste, जो मैं आपको बता चुका हूँ बेटा, जो बता रहा हूँ डिस्कस कर रहा हूँ आपके साथ. Okay, so that's why the other countries are so successful in handling or managing their municipal kind of waste, because they segregate a source, that they have a detailed characterization of the waste. Once they have a detailed characterization of the waste, they know this waste should go to this particular facility. This waste is going to this facility. This waste is going to this facility. Okay, based upon what? Based upon these properties which I am discussing right now. I'm going to discuss with you right now. Okay, so approximate analysis include certain tests like these kind of things, and these tests are readily available, so readily doable at any particular lab, or it can be get done. Moisture content, volatile combustion matter, carbon, ash. Okay, now what is moisture content? You know how much moisture is present. कैसे होता है ये लिखा हुआ, पढ़ लो उसके बारे में. It can be determined by the loss of moisture after heating at 105 डिग्री सेंटीग्रेड for 1 hour. तो 155 डिग्री पे 1 घंटे तक हीट करोगे तो जितना मॉइस्चर उड़ जाएगा बेटा सारा. ओके, वो कैसे निकालोगे? वे करके निकाल लोगे. पहले सैंपल वे कर लो, एक घंटे बाद वे कर लो, और जो दोनों का वे का डिफरेंस आया वो मॉइस्चर आया जो पहले प्रेजेंट था अब उड़ गया. Okay, volatile combustion matter. So this is again the additional loss in the weight. उसी को आप 500 डिग्री पे या 900 डिग्री पे हीट अप कर दो. ओके, और जो वोलेटाइल उसमें कंटेंट है वो रिमूव हो जाएगा. फिर वे का डिफरेंस ले लो, जो डिफरेंस आएगा वो वोलेटाइल कंबशन मैटर है, और जो रह गया वो फिक्स है. एंड उसके बाद ऐश जो मैंने आपको बताई थी बेटा. ओके, सो proximate analysis is basically when you want to talk about, give you these things: moisture, ash, volatile carbon, and fixed carbon. Okay, so moisture and ash both represent the non-combustible component. So we don't require excess moisture, we don't require excess of ash. क्यों? जितना moisture ज्यादा होगा, पता ही आपको बेटा. वुड जलाते हो ना कभी कभी गांव में देखा होगा कि वुड बर्न करते हैं तो दे ट्राई टू हैव अ ड्राई वुड. वेट वुड का क्या होगा बेटा? वेट वुड से क्या होगा कि वेट वुड में अगर आपका वेट वुड ले रहे हो या वेट फ्यूल ले रहे हो, उसमें आपका मॉइस्चर ज्यादा है, तो नो डाउट जो नीचे हम उसको बर्न कर रहे हैं, बर्न करने के टाइम मैक्सिमम एनर्जी चल जाएगी मॉइस्चर को इवेपोरेट करने के लिए. तो लॉट ऑफ एनर्जी इज बीइंग वेस्टेड फॉर रिमूविंग द मॉइस्चर. फर्स्ट मॉइस्चर निकला, फिर वो बर्न करना स्टार्ट होगा. ओके, सो मॉइस्चर एंड ऐश आर अनडिजायरेबल. जस्ट सी दिस, दे ऐड वेट विदाउट एडिंग हीट वैल्यू. ठीक है जी, सिर्फ हीट वैल्यू को कंट्रीब्यूट नहीं कर रहे, वो मैक्सिमम वेट को हैंडल कर ऐड कर रहे हैं. ठीक है, तो हमें बहुत इसमें प्रॉब्लम है चीज के लिए. और ऐश का सबसे बड़ा एक ड्रॉबैक ये है जो नीचे लिखा हुआ लास्ट पॉइंट, ऐश रिटेन्स द हीट when removed from the furnace and thus resulting loss in heat recovery. जब आपने कभी ऐश देखी होगी ना, जो कोल की ऐश निकलती है, कोल जब बर्न हो जाता है तो नीचे ऐश जब बनती है तो ऐश रेड हॉट होती है, तो दिस मींस ऐश अपने साथ हीट रिकवर ले जाती है। तो हीट जो एक्चुअल को सप्लाई होनी चाहिए कि सरफेस को, इसके लिए हम यूज कर रहे हैं, दैट हीट इज बीइंग वेस्टेड इन द टाइम ऑफ ऐश। सो वी नीड टू हैव वेरी केयरफुल एग्जामिनेशन ऑफ दिस काइंड ऑफ, ठीक है। So two main things which are very important, that's the volatile and fixed carbon are the preferred indicators of combustion capability. So volatile is what? Volatile matter is a portion converted to gas as temperature increases, and fixed carbon is a solid carbon residue that remain on the furnace grate. और ये जितना रह जाता है ना fixed carbon, red hot रह जाता है, यही हीट करता है। आपने कोल बर्न किया होगा अभी, है ना? कोल बर्न करने के टाइम देखना कि कोल मैक्सिमम हीट तब देता है जब कोल रेड हॉट हो जाता है, और रेड हॉट होने के बाद ही वो हीट अप देता है। तो आपका फिक्स्ड कार्बन है बेटा, जो जल रहा है रेड होता है। आपने बारबेक्यू पे देखा होगा ना बेटा, तो बारबेक्यू में हमने देखा होगा वो नीचे है, वो अपने रेड हॉट हो रखे होते हैं और उसी हीट से बारबेक्यू चलता है। फिक्स्ड कार्बन, ओके। So generally when talk about percentage of fixed carbon, it is 100 minus moisture, 100 minus moisture and ash and volatile content, okay. So if you have some doubts while I'm discussing, you can write it down, and before I end the class, you can ask. So this is something I'm talking about. You can go through. This is how I'm describing a different kind of waste, mixed paper, mixed food. You have these kind of waste which actually coming out. Mixed paper, you know very well. Mixed food, you know, from the hostel waste, institutional waste is coming out, right? So they have a different kind. See, the highest moisture is then mixed food. Okay. And then volatile is also there. But see, you see the mixed plastics, they are having a maximum volatiles and least particular moisture. Accordingly, they can be handled. But you need to have an idea about the energy content in the municipal solid waste. अब एनर्जी कंटेंट क्या होता है बेटा? एनर्जी कंटेंट यह है कि आपने उसको ऐसे देख लिया, एनर्जी कंटेंट देखनी पड़ेगी कि व्हाट इज द कैलोरीफिक वैल्यू ऑफ द फ्यूल पर ग्राम ऑफ द वेस्ट। यस, कैलोरीफिक वैल्यू, एनर्जी कंटेंट। अब थर्ड पार्ट है एनर्जी कंटेंट। एनर्जी कंटेंट इज very simple beta. Energy content is how much energy is released when the 1 gram of waste is being burnt. ओके और एक किसके लिए जरूरी है? जब वो उसको हम बॉयलर में यूज कर रहे हैं, इसको हम सिस्टम में यूज कर रहे हैं, इंसिनरेटर में यूज कर रहे हैं। तो अगर हम उसको यूज कर रहे हैं ना बच्चे, यू नीड टू हैव अ डिटेल एनालिसिस ऑफ एनर्जी। पता लगा आप 10 केजी बर्न कर दी और 10 केजी बर्न करने पे एक्चुअली 5 केजी ने हीट रिलीज की और बाकी ने हीट रिलीज नहीं की। और कैसे पता करेंगे हम? We have a bump calorimeter in every institution. आपके मैकेनिकल में भी है डिपार्टमेंट में, you can go through when you come, you can go through that particular instrument, bump calorimeter. Now the bump calorimeter is used to measure the release of heat of combustion. This is the formula, beta. You can go through and please go through these formulas. I'm explaining all these kind of things, the standard formulas, and all these basis of formula you will getting a numerical very soon. Very soon, I'm going to declare something regarding the internal assessment test. Just wait for some time. Okay, so this is the formula for getting a energy content in the waste. See this, it's U, heat value in calorie per gram, which I'm discussing over here, of unknown material. And this is CV, delta TM, these all values are there in the bump calorimeter. When you do this bump calorimeter experiment, mass of sample taken, the temperature rise delta T from the thermometer, you can rise, you can so notice heat capacity is a standard of that calorimeter, you can note it down. Okay, then this will give you the U, that is the calorific value. That is how much energy is being stored per gram of the waste. Okay, I think so you might see this. Now read this slide very fast, beta. It's up to you, beta, please. So I have explained to you everything. So my request to all of you to go through this beta very fast. Okay, so I think so I've explained each and every part of what is there being written over here. Okay, so now please you note down this particular expression, because on this kind of basis of these kind of expressions we are going to give you certain numericals in the coming without dates on the basis of internal assessment. Okay, so this is the formula once we're talking about energy content in municipal solid waste. So there are different formulas which are available in literature depending upon who invented this kind of formula. Okay, depending upon certain parameters. Like first formula is Dulong formula. Dulong formula, and this is based on the ultimate analysis. You know, this is ultimate analysis which I told you. It's a basis of individual elements as estimation, carbon, hydrogen, all kind of stuff. So the Dulong formula, he basically his team, he invented the energy content of the waste on the basis of the individual analysis. So Dulong formula give you the heat content of the waste, that is in millijoule per kg, by using this expression. You can note it down or you can click the photo. It's up to you. Okay, that is this carbon, and this is on the basis of stoichiometry beta or dimensional analysis, nothing more than that. Okay, जो ये 33.7 है ना and 144.9 H minus over 8 plus this is nothing but based upon the dimensional analysis. Based upon dimensional analysis, how when the problem is being solved, what's the formula is being reached out, and this is something I'm talking to. Okay, so if you see below, there are certain examples. So food waste ka we have taken an example. For food waste, we have taken the heat value of the food waste based on the values of carbon, nitrogen, oxygen, sulfur, all things are being given. Accordingly, they are being used over here. Okay. Now, this is the second formula. There are different kind of formula, but depending upon which criteria is being chosen. Okay. Second is the Khan formula. If you see this Khan formula, but Khan formula is based upon the segregated composition. When the segregated composition is known, okay, that is, see this, E is energy content, that is millijoule per kg. According to this formula, F is the fraction of weight of food waste, CP cardboard waste and paper waste, and PLR is the plastic and rubber waste. So you have a segregated waste. Okay, like in India, we don't have segregated waste. We have a different kind of waste coming dumped together, taken together. So that waste sample can be taken. And when the waste sample is taken, you can go for ultimate analysis, carbon, hydrogen, all these kind of things we can take out. But in other countries, when you have segregated waste, I think so segregated waste, segregated means plastic separate, rubber separate, glass separate, food separate, this separate. So on the basis of that, if you have that kind of data, you can use a Khan formula to calculate the heat content of the waste, energy content of the waste. Okay. Is that okay, everybody? So then another property is the fusing point of ash. You just go through it. Fusing point is a very important property. That is, at what particular temperature is going to, the waste is going to fuse to make a clinker. You know clinker, ये देखो आपके सामने बेटा clinker देखा होगा कि अगर आप उसको बहुत हाई टेम्परेचर पे हीट कर दोगे ना, तो वेस्ट क्या करेगा बेटा, वेस्ट इज फ्यूजिंग पॉइंट पे पहुंच जाएगा अपना. फ्यूजिंग पॉइंट पे क्या होता है, उसके क्लिंकर बन जाते हैं. एंड दिस क्लिंकर इज रॉक सॉलिड, and this rock solid is very hard to dispose of, and it's going to have a waste impact. Okay, so you need to know the waste you're going to handle at what particular temperature it's having a clinker formation. Normally for the municipal solid waste, normal range is 1100 to 1200 degrees centigrade where the clinker formation starts, and you don't want clinker formation to get started because ultimately all the heat is being lost. हीट भी लॉस हुई, 1100-1200 डिग्री तक जाने के लिए हीट भी लॉस हुई, क्लिंकर बन गए, क्लिंकर बन के उनको डिस्पोज करना डिफिकल्ट है बच्चे. ओके, देन यू आर टॉकिंग अबाउट नेक्स्ट प्रॉपर्टी इज द कंटेंट ऑफ न्यूट्रिएंट अदर सब्सटेंस. अब ये कहां पे आता है बेटा, कंटेंट ऑफ न्यूट्रिएंट अदर वेस्ट. अब कुछ वेस्ट ऐसा निकलता है, कुछ नहीं, काफी वेस्ट इंडिया में ऐसा निकलता है, दैट कैन बी फेड टू कंपोस्टिंग, वर्मी कंपोस्टिंग एंड सम अदर थिंग्स. और जब कंपोस्टिंग, वर्मी कंपोस्टिंग में लेके जाना है, तो यू मस्ट बी नोइंग अबाउट द न्यूट्रिएंट वैल्यू. न्यूट्रिएंट्स क्या होते हैं बेटा, न्यूट्रिएंट ये आपके सामने. organic acids, starch, sugar, proteins, amino acids, lignins, fat, all this kind of stuff. वो कहाँ से आते हैं बेटा निकल के? एग्जाम्पल दे रहा हूँ बेटा, आपका फूड वेस्ट जो मैसे वेस्ट होता है, नॉट थापर, एवरीवेयर इंक्लूडिंग थापर, ओके। तो फूड वेस्ट जो निकल के सामने आता है, एक होता है प्रोसेस्ड, एक होता है अनप्रोसेस्ड। अनप्रोसेस्ड होता है जो आपके ये छिलके हो गए प्याज के, यू नो सैलेड और काइंड ऑफ स्टफ। एंड प्रोसेस्ड इज व्हाट यू, राइस हो गई, दाल होगी, सब्जी होगी, बच्चे, दैट प्रोसेस्ड फूड, ओके। Now all this food is coming out in a huge quantity from the horses, every horses. So this waste is having a very good amount of nutrition value, nutrients. Why I'm saying nutrition value, खाना नहीं है, means it can be converted to some products. Okay, see this. Nutrient content defines the potential of municipal waste to provide nutrition to microbes. So my microbe की बात कर रहा हूँ बेटा. Okay, so when your food waste is nutritious, the microbes will use that nutritious food to degrade it and to convert it to compost. That is very much important. I'm going to show you beta actual photographs of those countries coming days, fine, to show you to give you a glimpse of what they are doing for this kind of waste in this country. That's why their countries are so beautiful. They are producing tons of compost in a single day. Okay, so ये concern है बेटा. Okay, so these are some other particular thing which I want to share with you. Then you have carbohydrates content, all these things, or sugar content you can always calculate. You have a facility, every lab in Thapar University, like in biotechnology, in our department, some other department, some other chemical department, you go though, you can calculate all this content very easily. Okay, lipids, proteins, then biodegradability of. So lipids is basically talking about fat, oils, all kind of things. Proteins you're talking about the nitrogen component, you know very well. Okay, these things can be easily calculated using instruments available in the university or designated points. Now, when we're talking about physical properties of solid waste, some of the physical property I'm discussing is the density. Density is very much important. It provides information for predicting the storage volume. When you need to store this kind of waste, you need a huge kind of storage volume. So that's why you need to work on the density. In what way? See this. This provides information for predicting the storage volume when as discarded, when as compacted during collection. Okay, so as compacted at a landfill. Landfill क्या है? With time आने वाला discuss करने वाला हूँ. I'm going to show you. ठीक है? So the density of the waste. See this. आपके घरों में जो waste निकलता है वो uncompacted है. पूरा वो भर जाता है. तो आपने कभी किया है कि ऊपर से प्रेस कर दो अपना जो डस्टबिन है, डस्टबिन के अंदर जाओ और जो वो आपके है वो प्रेस कर दो. प्रेस करोगे बेटा तो वेस्ट नीचे बैठ जाएगा, और स्पेस बन जाएगी, वो कंपैक्टेड वेस्ट हो गया. सो डेंसिटी ऑफ रॉ अनकंपैक्टेड वेस्ट विल वेरी एज अ फंक्शन ऑफ कंपोजिशन. कंपोजिशन क्या है? अब उसमें अगर पूरा वेट वेस्ट है जल्दी कंपैक्ट हो जाएगा, वेट वेस्ट नहीं है, ड्राई वेस्ट है, प्लास्टिक है, कैन है, तो वो कंपैक्ट नहीं होगा. मॉइस्चर कंटेंट कितना ज्यादा है, ओके, शेप क्या है, डिग्री ऑफ कंपैक्शन क्या है. सो डेंसिटी इंक्रीजेस विद इंक्रीज इन द प्रोपोर्शन ऑफ सेरेमिक्स, एशेस, मेटल एंड मॉइस्चर. ओके, see this. You might have seen these kind of stuff. Saying this is called balers. And see this whole waste which is littering over here. Okay, it's going to cover a huge area. But this whole particular waste can be compacted using a machine called baler to convert it into a small cuboid shape thing, which is having a highest density. Okay, why we need this? अब देखो, अब इसको ट्रांसपोर्ट करना और इसको ट्रांसपोर्ट करना, हाउ फार इट्स वेरी इजी और डिफिकल्ट. So this littering can be converted to this baler, and this density increases. This can be handled very easily, and less volume is required for transportation and storage also. Okay, see this raw waste की density ये वाली है, compacted की waste की density. See how much increase in there. Okay. So this is basically, you can note it down, you can click it, This on this basis, I'm going to execute certain numericals in coming lectures. Okay. So now you have a different materials. You have a glass, you have a cans, you have a yard waste, you have a food waste, you have kitchen waste. Now every waste which you are handling is having a different densities. तो हमारे यहाँ तो segregation है नहीं ना बच्चे. So when you don't have a segregation, you having every kind of waste, you know this percentage is this percentage this. So if this is there, then you can always calculate what overall bulk density. Overall bulk density is formula is this Ma plus Mb. Ma is a mass fraction of component A. Mb is a mass fraction of component B. A component is food waste. B component is yard waste. C component is, suppose MC is there, then it is maybe plastic waste. Okay? So you have a different thing. And accordingly, what kind of contribution by density by the individual fractions divided by Ma by rho A, Mb plus rho B plus Mc by rho C. Okay, so this is going to give you the overall bulk density of the waste which you want to handle, which contains all the waste. Okay, so that this basis you can define the compaction ratio R. So R is no doubt is always uncompacted density to the discarded density. Compacted density to the discarded density. Discarded means uncompacted. Okay, so you can click the photo for the formula, because in the coming lectures we're going to do certain numericals based on this thing. See this. ये अभी रहने दीजिए बेटा, हम करेंगे इस न्यूमेरिकल को, ठीक है. So the second physical property is a moisture content बेटा. अब moisture content क्या है बेटा? Go to the moisture content beta. Moisture content, I told you, I discussed with you, you can go through very fast beta. Okay, so it's useful for estimation of heat content. I think so. I told you, I told you for transportation requirement, so I explained you. Okay, तो moisture ज़्यादा होगा, transportation खर्चा ज़्यादा हो जाएगा, because वो heavy हो जाना है बच्चे. ठीक है, so it is expressed either on the wet basis or dry basis. On wet basis or dry basis, according to formula are different, and when I want to met this thing, moisture content formula, wet weight minus dry weight divided by wet weight into 100. This will give you the moisture content on wet basis. Okay, this is going to give you moisture on wet basis because we have divided by wet weight. Okay, accordingly this can be calculated. Then particle size distribution. Oh, this is required for improving the rate of chemical reaction. So because if the particle size is good, the rate of chemical reaction will be good, more burning will be there. Okay. कैसे कोल को बर्न करते हैं, टाइम लगता है, लेकिन कोल को हम उसको क्रश करके छोटे साइज में कन्वर्ट कर दें, सरफेस इंक्रीज हो गया, तो मेरे ख्याल से आपका बर्निंग एफिशिएंसी बढ़ जाएगी. एंड फोर्थ particular property is very much important is the field capacity. Okay. Now what is field capacity beta? You can go through field capacity. See this. It's a marked total amount of moisture retained by the mixed solid against the force of gravity. होता क्या है बेटा? फोर्स, मैं इसकी डिटेल बताऊंगा जब मैं लैंडफिल में डिजाइन करूंगा. देखो आपका वेस्ट पड़ा है, अब वेस्ट में पड़ा है, तो वेस्ट में कैपेबिलिटी है कि कुछ मॉइस्चर को रिटेन कर लेगा और कुछ मॉइस्चर को रिटेन नहीं कर पाएगा. उसको बोलते हैं बाउंड और अनबाउंड मॉइस्चर. तो बाउंड है जो उसने बाउंड करके रख लिया, वो बाहर नहीं आएगा बेटा, अंदर पोर्स में चला गया वो. और जो अनबाउंड है, जो एक्सेस है, वो लीचेट होकर नीचे आएगा, उसको लीचेट बोलते हैं, जो इसकी डिस्कशन मैं लैंड फिल्म में बहुत डिटेल में करने वाला हूँ. अभी समझ लो सभी बेटा, फिर मत पूछना कि लीचेट क्या है, मैं रिपीट नहीं करने वाला. एक्सेस ऑफ फील्ड कैपेसिटी रिजल्ट इन लीचेट मींस जो पानी नीचे आ गया. ये देखो, ये आपका वेस्ट है बेटा, अगर थोड़ा मैं एक्सपेंड कर दूं आपको दिख नहीं रहा तो ये देखो, ये सॉलिड वेस्ट है जो डंप कर रखे है, रेन आई. ओके, अब फील्ड कैपेसिटी के अकॉर्डिंगली जो एक्सेस में है वो नीचे फ्लो कर गया, ये इसको बोलते हैं लीचेट. जो रिटेन कर गया वो फील्ड कैपेसिटी है उसकी. ठीक है, तो इसकी वजह में रिटेन हो गया, और जो एक्सेस है वो लीचेट वो नीचे आ गया, देखो नीचे आ गया ना बेटा, और ये है लीचेट, और लीचेट बहुत ही डेंजरस है ये वाला। क्यों? मैंने बताया था कि लीचेट वो होगा जो सॉलिड से बीच में होके आएगा, बीच में होगा क्या, तो सॉलिड में हर चीज डंप है, वेस्ट है, हजार्डस वेस्ट है, सम अदर वेस्ट है, केमिकल वेस्ट इज देयर। सो जो पानी आएगा परकुलेट होके, that will actually dissolve the harmful components, hazardous components, and it will leach out. And this leachate is too dangerous. And we don't want this leachate should go to the groundwater. Ultimately, it goes to groundwater. If it goes to groundwater, it's going to contaminate the groundwater, and it's going to contaminate the resources, natural resources of water. So that's why it's being recommended when you want to discuss these things in detail in coming lectures. This leachate should be treated so that we can get rid of these kind of hazardous materials which are present in the waste. Okay. I hope you have understood this what I'm explaining to you. And this is field capacity. But you know what is field capacity? बच्चे पढ़ लो बेटा उसको, अभी बता के जो field capacity में आपको, है ना? And kindly please click this particular photograph also, because you might be getting a numerical base from field capacity also. The field capacity, no doubt, is varies with the degree of pressure applied and degree of state of compaction. What state of waste is you are having? Okay, so formula is this. See this. FC, field capacity is equal to 0.6 into 0.55 W by this. And what is W? W is the overburden of waste. Calculate the mid height of the waste in lift. That is, इसके डिटेल में मत जाओ बेटा अभी, ठीक है, मींस ओवरबर्डन ऑफ द वेस्ट, दैट इज मिड हाइट से ऊपर जितना भी है बेटा, वो हम एक कैलकुलेट करते हैं, जिसके लिए एक फॉर्मूला है, उसके अकॉर्डिंग हम कैलकुलेट करते हैं. ओके, FC is a percentage of dry field capacity, that is percentage of dry waste of the waste. Okay, no. Hydraulic conductivity you can go through as your own, because I'm not going to explain everything. So you just go through the hydraulic conductivity. It's very simple beta, I have explained you. लीचेट बता चुका हूं, उसी का पार्ट है बेटा. It's not that I'm not explaining to you, it's already I've explained to you. But moment I'm explaining to you, I want you should go through at least for some of the content so that you get the idea what I was explaining. Okay, so these are some videos which will give you the ideas of solid waste management in different kind of cities, and how the things are actually being happening in some of the cities where they are really going up for these kind of solid waste management practices. Okay, so I'm stopping here because time is always 9:35, 9:40 I have to leave. So if you're in doubt, you can ask me, bache, and thank you very much.